Hello, fifth graders. Welcome to our next lesson of force and motion. This is lesson 5. In lesson 5, we are going to learn about potential and kinetic energy. Our learning target for today is I can explain what potential energy and kinetic energy are. On slide 15 of your student activity packet, there are some vocabulary words. These are our vocabulary words of this lesson. The first one is kinetic energy. Kinetic energy is energy in motion. Our second word is potential energy, which is stored up energy that is waiting to be released. Please pause and type these vocabulary definitions into your student activity packet. In our last lesson, we learned about gravity. Gravity is the force that pulls us back to Earth. We also learned about friction. Friction is the force that slows down an object. The more friction, the harder an object works to move. The less friction, the easier it is to move. The force of friction can fight against the force of gravity, and different surfaces affect the movement of objects. In this week's lesson, there is an article to read called Full of Energy. You can read this on your own. It's attached in Google Classroom. Or there's a video of me reading it aloud if you would like me to read it to you. To continue the rest of this video, I'm going to do a short experiment. In this week's short experiment, I have a marker that is attached to a string, and we're going to learn about potential and kinetic energy. So I'm going to hold my string upright like this, and you can see that the marker, it wiggles a little bit, but it doesn't really move. Now, if I were to change this position and I were to tilt it just slightly, when I let go of the marker, what do you think will happen? It's going to swing back and forth, right? So here, right here, this is what we call potential energy, because we know that it's going to move when we let go, but right now it's not moving. It's energy that is stored up. When I let go, now it has kinetic energy, energy in motion. In your book, this is the position of string A. What if I move it to string B? If I move it just slightly up higher, what's going to be the difference from here to here? Let's let go and find out. Right now it has potential energy, and now it swings even further. It has more kinetic energy. You can see that it eventually slows down. String B is right here. It has more potential energy than if I just hold it a little bit tipped. Well, what if I bring my string all the way up here? If I bring my string all the way up here, you can tell that it's going to swing a lot farther than either of the times I've done this before. It has lots of potential energy right now. And when I let go, it'll have kinetic energy that swings it back and forth. And then friction slows it down. So the higher away, the more gravity that it has pulling against it, the more kinetic energy an object has. In your student activity book, you have a diagram that looks like the experiment I just did. When I held the string at position A versus position B or position C, which string went the furthest? Well, if you remember, string C went the furthest because it had the most potential energy. It had the furthest room to swing. An object that is put into motion because of a force. So before I let go, it was just sitting there. I had to have the force of letting go. An object in motion has kinetic energy. That means that it's allowed to swing back and forth. The crayon or the marker was showing its energy by swinging back and forth. Gravity pulled the crayon back down after I lifted it. These fill-in-the-blank questions are in your student activity packet. Make sure you're filling them in as we go through. An object's motion will eventually stop because of friction. The kinetic energy changes back into potential energy. We can tell that the crayon began to lose its kinetic energy because it doesn't swing as far or as fast or as high. What can cause the crayon to have motion again? Well, when I lifted it back up, we know that it's going to move again. In your student activity packet, there's also a diagram that looks like this. In this example, we're going to go from the left to the right. It says before the tennis ball is thrown up into the air. So right here I have a tennis ball, and I'm about to throw it up into the air, but I haven't yet. Before I throw it up into the air, it has potential energy because it is waiting to move. Then, once I throw it up into the air, the ball has kinetic energy because it is moving. As it continues up this path, now it has potential energy because it is slowing down and gravity is starting to pull it back down to the ground. After this turn, though, that's when gravity takes hold and it increases the kinetic energy because now it is being pulled back to Earth. So it slows down and then speeds back up. And lastly, when the ball is caught again, the energy changes back into potential energy until it is ready to be thrown up again. So all energy changes back and forth between potential and kinetic. Let's try another example. It says, a skydiver jumps out of a plane. Is that potential or kinetic? That's potential because he has the ability to move, but he hasn't jumped yet. What about a person pulls back on a bow and arrow string before they let go? So they have it all pulled back and they're waiting. Well, that would be potential because it's going to move when we let go, but it isn't moving yet. Our next example, a soccer ball flies into the air once it is kicked before it falls back down again. So that's like our example with the tennis ball on the first page. That would be kinetic energy because it's kicked up into the air and then we're waiting before it falls again. And here's our last example. A pine cone drops from a tree to the ground. Well, that would be kinetic energy because it's up high and it has the ability to fall. Once it starts falling, that's kinetic energy. Great job with this lesson, friends. Make sure before you're finished that you go back and you complete the journal and the reflection activity in your student activity packet. Great job, 5th graders.